Alright, remember, we move to another special area in trigonometry involving reciprocal ratios. What are we talking about? Let us see. There we are. So here we have two sub-questions. Each one deals with a specific reciprocal ratio. Then later on, I do a summary to cover all of them that are involved in our trig system. If you've covered them in class, here are the challenges. Do them, pause, then you can follow the video, check yourself, and then also don't forget the summary. Remember, enjoy. Alright, remember, let's go for it. I hope you went well with it. Let's see if you nailed it. Right, as I said in the intro, we are going to do this one for the purpose of laying a foundation for the trig that we will encounter in our exams, our other tests, and so forth. Okay, so you've read it. Let's do it together though. So we are given this diagram and they say in ABC, ABC. Okay, so in triangle ABC, AB is R and AC is 1, the vertical, and BC is 2, the horizontal, which we can say base and height. Then they say determine the values of the following, and they give us these two sub questions. All right, let's see. Now for the first one, we have what, 3.1.1, and what do we have there? We have sine theta minus cot theta. So in an exam, you are not going to waste time. You are going to say this one is what? It is opposite over hypotenuse. And then what about this one? Opposite over adjacent. Then you got it wrong. Right, this one is adjacent over opposite, isn't it? Okay. Then what is our h? What is our h? Our h is, right, let's do this, equals both. Okay. Then opposite our theta. Let's look at the picture on the left. So hypotenuse is r. So we put r. And opposite what? Opposite that angle there. Okay, so these two are next to or connected to this angle, so we don't use those. Okay, we use the side opposite. All right, so which is what? Which is 1. All right, then what is a? So you've got two angles, two sides rather, that are what? That are making this angle. So we call this one adjacent because that one, obviously, it is our hypotenuse. So this one is adjacent. So it means we have a 2 and we have just discovered our opposite is 1. All right. Then we simply simplify. So our, what is it? LCD will be what? Will be r. Okay, I intended to make it here. Okay, it is r, and if this is r, r goes there. What? R times, isn't it? No, it goes once. Okay, so 1 times r will be 1 times 1 will be 1. Okay, then this one goes into r times, then times 2 will be 2r. So we have 1 minus 2r over r. Then we are done. Okay, so that will be your 3 marks. So it is getting the correct ratios, then the substitution, and then your final solution. All right. Okay, so then when we're done, we'll go back to all of them just to recap on whatever that I will raise. Okay, right. Let's go for the second one. Alright, remember, here is the second one. So second one, what do they give us? 3.1.2. They give us 3 cos squared theta minus, is it minus? No, it is plus cosec theta. So if you are sharp like that, you are my member, you would know that this one would be what? Would be adjacent over hypotenuse. Otherwise, we can also say x over r, so that I also make you, conscious of the other symbolism that we use. All right, so this one will be x over r, and what do? We square that ratio to address that square there. All right, then this one, if you sharp like that, you know that it's associated to, what is it? It's associated to sine. Sure. Yes, it is associated to sine, isn't it? And then we know that sine is opposite over hypotenuse, isn't it? Okay, so I'm going to use opposite, which is what? Which is y over r, but we are doing the reciprocal, so it will be r over y. All right, then we go back to our diagram and see what do we have for x. So why do we use x? This side here, which is our adjacent, can also be referred to as x because it is along the horizontal plane. Okay, horizontal x-axis. So what are we going to have there? We are going to have a 2 over, what is r? R is r. Okay, then we square, we don't forget our 3. Then this side, what are we going to have? We're going to have our r again. And then what is opposite? Opposite is 1 once more. Okay, so there is our 1. So it is like that. Alrighty. Simplification. So I'm thinking about this 3. I'm going to address it when we just do some reflection, because I am observing that some learners could actually be tricked there. So 2 squared r squared plus r over 1. All right, then what do we have now? We have 12 over r squared plus r over 1, and our LCD, what is it? It is r squared. Goes there into itself once. 1 times 12, 12. Then 1 goes into r squared times. Then I will have what? I will have r cubed. Okay, so it means in the final analysis, that is our final solution. Then you are done. Alrighty. So if you have got it, well done. If you haven't, no stress. It's a transition, it's a journey. Then let us do some reflection. Right, let's start with the first one. I'm just gonna recap on some of the elements that we should be cognizant of. So in our foundation, we are told that we have a sine, then we have a cosine, then we have a tan, isn't it? Then later on, what are we told? We are told that each of these has a reciprocal, which is defined as follows with these ways, isn't it? All right. Then what do we know? This one, it is opposite over hypotenuse, or y over r, isn't it? Then this one, it is adjacent over hypotenuse, or x over r. And then this one is what? It's opposite over adjacent. Is it adjacent over opposite? This one always confuses me. right, opposite over adjacent. All right, then what happens here, we just flip those. What we'll have, h over o or r over y. Then here we'll have h over a or r over x. Then here o over a or x over, what is it? No, y over x. Oh, right. What do we have? We have opposite over adjacent. Ah, you see, I told you that this one, it will make you drill a little bit. Right. Just make sure that it doesn't do that. By the time you get your exam, you have cleared it in your mind. Okay. So here we will have x over y instead of y over x. Okay, I didn't write it this time. Okay. All right. So when you practice these and you internalize them, this is what you can do. Okay, you can choose one of these or these. Okay, so don't do this. It's gonna waste your time. Otherwise, if it does help you to organize your thoughts, you can also do this. All right, then everything else is about knowing the picture, isn't it? So I showed you in the video. So this time what do we have? We have this. So the angle that is given is there, theta. This one is our hypotenuse. Then this one is our, what is adjacent, all right? Or our x. So it's adjacent over x, and then this one is the opposite or our y. And then this one is h, hypotenuse, or it is the radius. All right, then everything else was what was substitution, and I trust you have followed that. Then in the other one, what did I address? I addressed, okay, here we had one of the reciprocal for 10, isn't it? Then here they gave us what? They gave us the reciprocal of sine, isn't it? All right, so we developed it, and then this is what we did. Then here, what do I have? I have a 12 there. Okay, it looks like 1 squared. Let me write it properly so that you don't say, I say that's 1 squared and then here it's 12. What are you doing? Right, so that is a 12. Then I said I wanted to address something. So one of the things that happen with many learners is that when they convert this into its, what is it? Let's say calculation mode, they make this mistake. They do this. They say 3 cos theta squared. All right, and it's going to be incorrect because this is not equal to that. Because what will happen here? You'll say 3 squared and then you'll have 9. And then whatever you have there, you'll square it. So it means you'll have your 4 over r squared, and then what is it going to be? It is going to be 36 over r squared, which is incorrect. All right, so just be mindful of that. It is only here. If ever they do this from the start, then you can proceed with this calculation or expansion. Anything that I want to address? I doubt. Okay, I doubt. We have laid the foundation, our right angle triangle, and all our ratios are there for us. So hopefully we can make use of this for any complicated or twisted, tricky challenge. Alrighty, member, thank you. Let's meet in another set of challenges.